All right, let's dive in. Today, we're talking about one of the absolute pillars of Azure, virtual machines. Look, whether you're studying for a cert or building your next big thing, you've got to know this stuff inside and out. So, let's get right to it.
So let me ask you this. Are you or is your company still buying physical servers? You know the drill, racking them, stacking them. For the longest time, that was just how it was done. But man, it is a process just filled with headaches about how long it's going to take, how much it's going to cost, and the constant worry of, did we buy too much or, even worse, not enough?
And this is where things get really different. The old way, it was just slow. You had this long procurement process, massive upfront costs, and all this tedious manual setup. And once you bought that hardware, that's it. You were stuck with it. But the Azure way? It just flips the script completely. You can spin up a server in minutes, you only pay for what you actually use, and you can scale everything up or down on a dime. It's a complete game changer for how we think about infrastructure. So, let's get to the heart of it. What exactly is this fundamental building block? What are we really talking about when we say a server in the cloud? So, what is it really? An Azure Virtual Machine is basically a computer that you rent from one of Microsoft's massive data centers, and it gives you all the power of a server you'd own yourself. You get to pick the operating system, Windows, Linux, you name it. You install your software, you configure the network, everything you do on a physical machine. The huge difference? You never have to touch a single physical box. It's all the control with absolutely none of the hardware headaches. It really is that simple. Instead of owning the computer, you're just renting it. And that one simple shift in thinking is what unlocks all the incredible flexibility and power of the cloud. Okay, so we've got our server in the cloud. That's great, but what happens if something goes wrong? A single server, I don't care if it's in your basement or in an Azure data center, is still a single point of failure. So how do we design a system that can actually survive when things break? And this is where availability zones come in. You see, an Azure region, let's say East US, isn't just one giant building. No way. It's actually made up of multiple physically separate data centers. Each one of those is an availability zone, and they all have their own independent power, their own cooling, their own networking. They're completely isolated from each other. It's exactly like having backup generators, but in totally different buildings. So by spreading your virtual machines across these different zones, you're building in resilience from the ground up. If a huge problem takes out an entire data center, a power grid failure, a network outage, whatever, your application just keeps on running because the VMs in the other zones are humming along, ready to take over. And what you get out of this is a massive boost in reliability. By using availability zones, Azure gives you a 99.99% uptime guarantee, or SLA. To put that in perspective, that's less than 1 hour of potential downtime over an entire year. Try building that yourself. The cost and complexity would be astronomical.
Now we've planned for hardware failure, which is awesome, but what about another really common problem? A sudden spike in traffic. Your app gets a shout out on social media and your user load just triples in an hour. How do you handle that without everything crashing and burning?
This is where virtual machine scale sets are an absolute lifesaver. A scale set is basically a group of identical VMs that's designed to automatically grow or shrink. You just set the rules. You can say something like, hey, if the average CPU across all my machines goes above 70%, add another one. Then, Azure just takes care of it, automatically adding new servers when demand is high, and this is just as important, getting rid of them when things quiet down so you're not paying for what you don't need.
I love this comparison because it just clicks, right? A restaurant wouldn't keep 10 cashiers working at 3 a.m., but you'd better believe they'll have them ready for that big lunch rush. Scale sets let your application do the exact same thing, perfectly matching your resources to the real-time demand. That means you get great performance without just wasting money. So scale sets use a strategy we call horizontal scaling, or scaling out. Let's be really clear on the difference here. Vertical scaling, or scaling up, is like upgrading your laptop. You're making one single machine more powerful with more RAM or a faster CPU. Horizontal scaling is more like hiring more employees. You're adding more machines to share the work. For almost all modern apps, scaling out is the way to go because it's way more flexible and, honestly, there's pretty much no limit to how big you can get. Of course, a virtual machine isn't just about CPU and RAM. It also needs storage, a place for the operating system and your data. And just like with compute, not all storage is the same. Picking the right disk type is a huge deal for both the performance and the cost of your whole system.
The options are actually pretty easy to understand. For backup or archive data you hardly ever look at, A standard hard drive is like a giant slow warehouse. It's cheap and it holds a ton. For your everyday web server, a standard SSD is like your reliable work van. It gets the job done with good balanced performance. But for your mission-critical database that needs mind-blowing speed, that's when you bring out the premium SSD. That's your high-performance race car.
And managing all this storage is incredibly flexible. You can attach a data disk to one virtual machine, and then later you can just attach it and reattach it to a completely different machine, all without losing a single byte of data. It's perfect for when you need to move a database to a more powerful server. It's literally as simple as unplugging an external hard drive and plugging it into a new computer.
All right, so we've covered resilience, we've covered scaling, we've covered storage. Now for the big question, how do we wire all of these pieces together to create a system that's truly robust and can pretty much manage itself? Well, the last key piece of the puzzle is the Azure Load Balancer. You can think of this as the single front door for your entire application. All of your user traffic hits the load balancer first, and its one job is to intelligently spread that traffic across all of the healthy VMs in your scale set. The traffic hop analogy is perfect here. It's preventing traffic jams by making sure no single VM gets all the work. But crucially, it's also constantly checking the health of each VM. If one of them becomes unhealthy or crashes, the load balancer sees that immediately and just stops sending traffic its way, seamlessly redirecting everyone to the servers that are still running strong. So, let's put it all together. Here is the blueprint for a modern, resilient cloud app. Step 1. You build your foundation on resilience by deploying your VMs across multiple availability zones. Step 2, you handle demand by grouping those VMs into a scale set. Step 3, you manage all the incoming traffic with a load balancer at the front. And the final, absolutely crucial step,
You automate the whole thing. I mean, trying to build this by manually clicking through the portal is just asking for trouble. It's slow and you're going to make mistakes. Instead, you use tools like PowerShell or the Azure CLI to script the entire deployment. That makes it repeatable, consistent, and super fast. In the cloud, automation isn't just some nice-to-have luxury. It is an absolute necessity if you want to manage things right.
So let's lock in the key takeaways from all this. First, virtual machines are your flexible, on-demand service in the cloud. Second, availability zones are your insurance policy against data center failure. Third, scale sets are your answer for handling unpredictable traffic automatically. And finally, load balancers tie it all together to create a high-performance, self-healing system.
We've gone over all the concepts, we've designed the architecture, but that brings us to the final, most important question. How do you actually build this? What does that first line of code even look like? And that, right there, is the perfect place to start thinking about your own projects. Thanks for joining this explainer.
So in this section of lab, we are going to do that administer virtual machines. So lab 08, manage virtual machines. So if you look here, the tasks, the very first task is that we are going to deploy zero resilient Azure virtual machines. You see here zone 1 and zone 2. So we are going to provision that one using the Azure portal. Second task is to this compute and storage scaling for virtual machines. Then after that, task 3 is create and configure Azure virtual machine skill sets. Task 4 is scale Azure virtual machines skill set auto scale routes using. And after that, we need go through task 5 is create a virtual machine using Azure PowerShell. And second option over there is using CLI. So let's start the app now. Minimize this one. So very first thing that we have to connect to Azure portal. Here I have already connected to Azure portal. Then search for. So going to prepare Cloud Shell for later use. So you click on this Cloud Shell icon. Select PowerShell. And this getting started screen, and select that mount storage account. Select the account subscription. then click on apply. Then I have to create a storage account. Click next. Then here select the resource group, select region. You can select STUS here. Give a storage account name and give a file share name. Then click on create. So deployment in progress. By the time, let's go back to, okay, let me open a duplicate account or so Cloud Shell is ready. Now let's go back to separate window, go to home, and let's look for virtual machine. Click on create and click on virtual machines. Here, subscription, select the resource group, give a virtual machine name. So select the region West US2 availability zone. So here availability zone and select that availability zone. Select here multiple zones. So now you can see just double it up. So I don't want that one. Edit names. So it will be here. Click OK. Security type is standard. Select the image. So for that, click on see all image. From the marketplace, select the Windows Server. Go select button, and here we are going to select Windows Server 2019. Windows Server 2019 data center x64 Gen 2. The VM architecture 64 x64. Done with Azure Spot discount. No. Size in T2S V3, which is 2 CPU and 8 gigabyte memory. That is fine. You can go with other. Okay, I have a need. No. Now administer account. Give a user account name for logging in and give a complex password. Inbound port rules, public inbound ports, select none. And the licensing options here we are unchecked. So next, disk. In the disk section, OS disk is image default, which is 127 gigabyte. OS disk type is premium SSD. That also fine. Now delete with VM. Yes, we want to delete. In our case, we want that one to delete. And when VM we delete VM, all the disk will be deleted. And then enable inter-disk compatibility. Unchecked is fine in our case. Then click on networking. So here, the networking interface. delete public IP and NIC when VM is deleted. So check this option. And load balancing option, make sure none. Then click next. This is in management section. We are not modifying anything with the Defender for Cloud Intra ID or auto shutdown that you can enable for the non-production or non-critical system to save some cost. Then it's going to monitoring section, just disabling boot diagnostic options. Then under advanced, we are taking all the default value. No bootstrap anything here, just default one. Click tags. We're not going to give any tags for now. Select review and create. When validation passed, click on create. So initializing deployment here. So I'll come back when those VMs are ready. So deployment is complete. Click on go to resource. So you can get the resources here. So now we are going to manage a compute and storage scaling for the virtual machines. So very first thing, when I'm in virtual machines, you see that availability and scope. Select that one, and we are going to change the default SKU for this one. So select the size, and currently you see that it's a D2S V3 current size, and we are going to change that to V4 series. So D2 DS V4, and click on resize. Here resize the virtual machine. Yes, so select that resize. So it's in progress now. Virtual machine resizing in progress. So it will take I think 5 to 7 minutes. So I'll be back when that is ready. So it was very quick. So resize virtual machine has been completed. And so we'll see the difference. Virtual machines, if I go there, when I provision both of them, I did not change this one. So that was D2 V3. Now this has been modified. So we have updated SKUs for this VM1. So now let's go for disk resizing. For that, so here now go to settings, go to disk, and then under data disk, just create and attach a new disk, because right now there is no additional disk unless that OS disk. So we are going to create a new disk here. So give it disk name, select storage type. For now we are selecting standard hard disk because we will modify this disk as a real scenario basis. So again, suggest this one, and we are going to apply. So you see the disk has been created, and this is currently attached with this VMM. So which is your data disk normally. So now what we are going to do, we just we are thinking, okay, we need SSD is not good enough. We need actually solid state drive. So for that, you need to detach from the host level. So detach that one. So I'm not deleting that disk. I'm just detaching from this server. So successfully updated. Now you see the disk is not there, but if I go to search for disks, so disks here, so select that one. So let me here from this disk settings, now here size and performance. So we are going to change that standard hard disk to solid state drive. So standard SSD. At the same time, you can go with a different sizing or different tier based on the IOPS or different throughput. So for a lab environment, that is fine. So click save. So save button. So it's updating the disk. So the disk has been modified to solid state drive. So if you see here, refresh the page, you see SSD now. If we go back to VM now, and the disks can just attach this time and not a new one. We are just going to existing disk. So select the disk here and click apply. So you can see disk has been added, and this is SSD, not HDD anymore. So now we will go through the virtual machine skill set. So for that, here in the search string, select for virtual machine skill sets. So click on create. Select the subscription, select the resource group, give a virtual machine skill set name, select the region, then availability zones. In our case, so we are selecting all 3 zones. Then orchestration section, we are selecting the mode is uniform. Then security tag, we are selecting standard. And the scaling options, we are selecting the default one, which is already selected. We are not changing for now. And image, get the image. We are going to do 2019 data center. So from the marketplace, select that Windows Server. Select Windows Server 2000 Windows Server 2019 data center x64 Gen 2. Is there any other option? Windows Server 2019 data center x64 Gen 2. Then give a administrator username, a password, and licensing options. Deselect that one, then click next options. So we are not going to use any spot instance. So considering of the default value, then next disk. For the disk tab, we are also accepting all the default value. We are not changing anything. The networking section, we're going to enable the networking. So first, there are three sections you will see. VNet, network interface, load balancing. So first, virtual network configuration, click on edit virtual network, and then give a virtual network name. Pass the address range. Delete this subnet. We are going to get a new subnet. Give a subnet name and give the starting address for this subnet. Then click on add. Click save. So next section is network interface. So here under the network interface, is the nick here. You can see that nick. Click on edit button to edit that network interface options. So here nick security group, select the advanced options and then click here, create a new one. So here name is fine. We are going to set up a inbound room and source fine, any source port range is asterisk, all destination any services. We are going to set this up for HTTP. Action is allow. Priority number is fine. Then give a for this inbound security room, give a name. Then click on add. So when we back to create network security group, we are not setting up any other, so that's fine. Now click on OK. Now here you see the public IP address, select enable, then click OK. Next section is load balancing. Here under load balancing option, we are going to create a Azure load balancer. Then down below, so let's select load balancer. So create a load balancer, click that option. And here give a load balancer name. So we are going to create a public load balancer. So click on create. So next on management section, we're considering all the default except we are disabling boot diagnostic. Next health section, we are just taking all the default value. We are not making any change here. Next advanced section, this also we are taking all the default value. We are not modifying anything. Tag, we are not modifying or adding any tag for our lab perspective. So click on review and create. So validation is in progress. So validation passed, click on create. So deployment is in progress. I'll be back when that is ready. So deployment is complete. Click and go to resource. So here you can see that virtual machine skill set is there. You can get all the properties. Now what we'll do, we'll scale this virtual machine skill sets. So for that, under availability and skills on left side, from these options, select scaling. So when you're going to scaling, there are two options. One is manual scale and custom auto scale. So for our lab, we are going to set up custom auto scale. So select that custom auto scale. And then you see that there's a auto scaling name. So and also the resource group. So what we will do, we are going to let's first and also see that scale mode. So two types of option is there: scale based on a metric, scale to a specific instance count. So click here, add a scale condition, and here we are going to set up based on metric. And when you set the based on metrics, then it's coming instance limit, minimum, maximum, and default. And if we this is default or this is ours one, not that one. This is based on a metric and instance limit. Select custom auto scale and add a scale condition. So let's select for a scale based on a metric, and for that add a rule. So first rule, we are going to add scale out policy. So what we are going to set that up, that when the average CPU load is greater than 70% over a 10 minutes period, and when the rule triggers, the number of VM instance is increased by 50%. So here the metric source resource type is under VM, and this is percent of CPU, and if this is greater than 70% for 10 minutes, then action will be increased percentage by so it will increase the 50%. Click on add. So this is for scale out rule. Now we are going to set up for scale in rule. So click another rule here. So virtual machine skill sets post percentage of CPU, and this time when that will be less for like below 30% over a 10 minutes period, it will trigger and decrease by 20%. So operator is less than this time, and threshold value is 30%. Duration for 10 minutes, and the action will be decrease percent by 20% decrease, and click add. And when that is done, click save button. Now for this rule, we also make sure the instance limit. So currently you see that instance limit minimum, maximum, default is 2. So we are going to set that up is minimum 2, maximum set that up to 10, and default is 2. So click on save button. You can monitor the number of instances from this page. You can see that instances. So if you select that one, from here you can see the number of instances. So now next task, we are going to create a virtual machines using PowerShell first, and then we use CLI. So let's go to CLI window, maximize that one. So now here, just think that when you are doing automation, then normally we are going to use all those in scripting. So that we are going to execute here. So let's execute the PowerShell command. So we are going to create a VM, new VM. So we can select two VMs here. So using PowerShell, press enter, give a name, user and password. So VM creation is in progress. VM has been created. We can execute a PowerShell command. You can see third VM is there. You can also refresh this page. I could just refresh here. Probably it can take time. Let's continue for the next task. So to stop this VM, we can just execute this next command, which is stop this newly created MyPS VM. Yes. That has been stopped. Let's check that command again to see the status. No, this one. So that is deallocated. So what actually it does when we stop any VM, so that means if there are any non-static public IPs, that will be released. Also, we do not like we are stop paying the virtual machine compute cost. So let's go to not this page. Actually, we have to go to VM machine space because that is cursor page. Here we can see that third VM that we created using PowerShell. So now we'll do using CLI command. So this time we're going to create a virtual machine using CLI. So we are going to bash just to make sure that we are in bash shell now. And execute the command to create a new VM. So that has been created. We can check with this CLI command. So you can see that VM is run. You can also go to here and see that put VM there. Now to stop that one, you can execute CLI command and like deallocate resource. Deallocation is done. If we can say VM is deallocated. So we can check that from here also. So those two VMs are stopped. So that is so far for this lab. Lab successfully completed, but it's always recommended to stop all the resources which no longer needed, or because it's a lab environment, so you can delete or remove the resource group. So that's it for this lab now. If you have any questions, please add that into comment section. Otherwise, see you in next lab.